Hey guys, Dean Chase here with another geometry lesson for you. Hope you're doing great. Let's go ahead and get this thing started with a word of prayer. Dear Heavenly Father, thank you for today, give us, Lord. Thank you for all you've done. I pray you'll bless my students. Help us have a great day. In Jesus' name we pray, amen. So today we're going to be learning about how to apply the sine and cosine ratios. This is lesson 7.6, page 473. So let's go ahead and get this thing started. So we've already learned the tangent ratio. Now today we're learning sine and cosine. The sine and cosine ratios are trigonomic ratios for acute angles that involve the lengths of a leg and the hypotenuse of a right triangle. So here you have sine of angle A is opposite over the hypotenuse. So the opposite over hypotenuse, and the cosine is adjacent over hypotenuse. Now there's a little acronym or whatever you want to call it to remember all these and keep them straight, which is SO, CA, TOA. Okay? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So say that a few times, SOHCAHTOA, 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 till you got it memorized so you can remember which functions you need to be using. So here we go, example 1. Find sine of A and sine of B. So we're trying to find sine of A and sine of B. So let's start with sine of A. And they want us to write the answer as a fraction and as a decimal rounded 4 places. So sine, so opposite over hypotenuse is 40, because opposite of A is 40, over hypotenuse, which is 85. So sine A equals 40 over 85. Which if we divide top and bottom by 5 is going to equal 8 over 17, okay? Which as a decimal is 0.4706 if we would type that in our calculator. About 4706, okay? Not too bad. Let's go ahead and do sine B. So opposite of B would be 75 because it's straight across, and the hypotenuse. So this is going to be sine B equals 75 over 80. Once again, divide top and bottom by 5, and it's going to equal 15 over 17. Okay? Which, as a decimal, equals about 0.8824. Okay. That was example 1. Not bad. Okay, this is a pretty long lesson, so we're just going to keep on cruising. Find cosine P and cosine R. Cosine P, cosine R, and write each answer as a fraction and as a decimal. So cosine, I'm just going to write this up here. Cosine is adjacent over hypotenuse. So of P, adjacent would be 5 square root 5 over 15. So cosine P equals 5 square root 5 over 15. That's going to simplify down to divide top and bottom by 5. The 5 disappears and this becomes a 3. Square root 5 over 3, which is about 0.7454. 0.7454, yeah. 0.7454. Okay? I hope that made sense. That was really fast. But let's keep going. Okay? Cosine R equals, so we have R, and adjacent to R is 10. Okay, adjacent meaning it's touching it, and it's not the hypotenuse, obviously. 10 over 15. Once again, both divisible by 5. They're really liking that today, aren't they? So that's going to be 2 over 3, which as a decimal is about 0.6667 to the 4th place, because it's 0.666 forever and ever. So let's keep going. That wasn't bad. A rope staked 20 feet from the base of a building goes to the roof and forms a 58-degree angle with the ground. To the nearest tenth of a foot, how long is the rope? So here we're obviously dealing with 58-degree angle right here, and we want to know the hypotenuse of this triangle and what is relationship to 20 and 58 degrees. That's adjacent to it. So we need something that has adjacent and hypotenuse. So if we think about sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. So we're going to be using cosine to solve this problem. So cosine 58 degrees equals adjacent, which is 20, over the hypotenuse, which we're trying to solve. So we're just going to call it x. Okay, just like yesterday's lesson or the last lesson, we're able to switch these. Okay, so switch to x and cosine 58. When you have x in the denominator, you could just flip them. So that's going to be x equals 20 over cosine 58 degrees. X equals 20 over, okay, cosine 58 degrees, we're going to go to that chart and we're going to find cosine 58 degrees, and that's going to be 0.5299. When we divide that out, x is going to equal about, okay, 37.7 feet. Okay, so right here we solved for the rope length, which is 37.7 feet, using this equation right here. You just really have to be able to look and say, am I going to use sine, cosine, or tangent? And I know I'm saying this a lot today, but if you can remember SOHCAHTOA, you're able to remember which one to use a lot easier. So try and install that in your brain, SOHCAHTOA. Okay, if you look up at an object, the angle your line of sight makes with the horizon is called the angle of elevation. If you look down at an object, the angle your line of sight makes with the horizontal line is called the angle of depression. Here's a little note. Apply theorems. Notice that the angle of elevation and the angle of depression are congruent by the alternate interior angles theorem, okay? Because these two lines are horizontal, so that makes them parallel, and these are alternate interior angles, so they would be congruent. Okay. Next problem, example 4. A pilot is looking at an airport from her plane. The angle of depression is 29 degrees. If the plane is at altitude of 10,000 feet, approximately how far is it from the airport? So here we know we have 29 degrees that we're going to be working with, and the sides we have in relation to 29 degrees are opposite and hypotenuse. So which function or which trigonomic ratio deals with opposite and hypotenuse? Sine. So, right, opposite over hypotenuse. So sine 29 degrees equals opposite, which is 10,000. That's a nice big number. Over x. Okay, so we could flop those around. X equals 10,000 over sine 29 degrees. X equals 10,000 over sine 29. If we go to the chart, it's going to be 0.4848. So x is going to equal, when we do that division in our calculator, 20,627. 20,627 feet. Alright, I hope that made sense. Not a super hard example. Let's go ahead and keep going. Example 5. A dog is looking at a squirrel at the top of a tree. The distance between the two animals is 55 feet, and the angle of elevation is 64 degrees. How high is the squirrel and how far is the dog from the base of the tree? So we know that right here the hypotenuse is 55 feet And this angle measure is 64 degrees. So in relation to 64, y is adjacent and x is opposite, and both are dealing with the hypotenuse. So we know we're going to do cosine and sine to solve for each of these. So to solve for y, that's adjacent. So that's going to be cosine, because cosine is adjacent over hypotenuse. So let's go ahead and do that. Cosine 64 degrees equals adjacent over hypotenuse, so y over 55 degrees. Okay. Cosine of 64. So now to solve this, we're going to multiply. Oh, why did I put 55 degrees? Sorry. 55 feet. To solve this, we are going to multiply each side by 55. So cosine 64 degrees times 55 is going to equal y. Okay. Now we have to find out what cosine 64 is. We go to the chart. It's 0.4384. 0.4384 times 55 equals y. And y is going to equal 24.1 feet. 24.1 feet. Okay. That was solving for y, and we use cosine. So obviously to solve for x, we're going to have to use sine, which is going to be sine 64 degrees again, equals x over the hypotenuse, which is 55. Solving it the same way, sine 64 degrees times 55 equals x. Sine 64 degrees equals 0.8988 if we go to that chart, 0.8988. And sorry, if you're watching this video for the first time today, go ahead and pop back to the last video I made, and you can see the trigonometric ratios chart I'm talking about. Or you could just look it up on Google. 0.8988 times 55 equals x. So x is going to equal about 49.4 feet. Okay? So x is how high the squirrel is, which is 49.4 feet. And then y is how far the puppy is from the base of the tree. I always use a Newfoundland because that's the dog I have. Anyways, let's keep going. Last example, guys. Use a special right triangle to find the sine and cosine of a 45-degree angle. So we know that if it's a right triangle and one of the degrees is 45, the other degree is 45, and that triangle has special relations, okay? So I'm going to go ahead and draw that triangle, okay, which is 45 degrees and 45 degrees, and this is 9 degree. We know that the legs are both equal to each other, and the hypotenuse is the leg times square root 2. So let's just go ahead and say we're looking at this 45-degree angle. If we were to do sine being so, which is opposite over hypotenuse, that would be x over x square root 2. Okay? But the same thing, if we were to do cosine, which is ca, which is adjacent over hypotenuse, it's still just x over x square root 2. So what I'm saying there, don't worry, I'm going to put it on paper. Sine and cosine are going to come out to the same answer, okay? Because our opposite leg and our adjacent legs are both the same, so it doesn't matter which you use. So we're going to go ahead and do this as cosine first. Cosine, ca, adjacent over hypotenuse. So cosine 45 degrees equals x over x square root 2. Okay. This becomes x over x is just 1, so we can have 1 over square root 2. Cosine 45 degrees equals 1 over square root 2. We learned that this is not an appropriate answer. You should not have a radical in the denominator, so to get rid of that, we're going to multiply top and bottom by square root 2. Okay? cosine 45 degrees becomes square root 2 over 2, because if you have square root 2 times square root 2, that simply just becomes 2, and 1 times square root 2 is just square root 2. Like I said, cosine and sine are both going to be the same, okay? Oops, sorry, square root 2 over 2. Because the opposite and adjacent are both the same measure. Okay. Guys, that's a whole lesson. That actually went a little bit quicker than I thought it would. Thanks for sticking with me. Thanks for following along. Please feel to like and subscribe to my channel. And you guys, you know what? Have a good day. See ya!